Welcome to the presentation of our paper on designing programming error messages for novices, readability and its constituent factors. Let's now take a look at two students working in a typical computer lab.
And run. 45 errors? The name I does not exist in the current context? What does that even mean?
I have no idea. Mine says no reference exception. That doesn't make any sense either.
Unfortunately, these kinds of frustrating experiences are all too common. Novice programmers struggling to make sense of cryptic programming error messages. Such error messages are a type of feedback produced by software called a compiler or interpreter, which indicate there is some kind of error in the source code written by a programmer. The cycle of program input and error message response represents a fundamental interaction between human and computer. While error messages can be confusing and frustrating even for professional programmers, they can be paralyzing for novices who are just beginning to code. Consider this example, which involves a compiler for the C programming language. This is a popular language used in many introductory programming courses. The student here is attempting to write the code statement shown on top, but they make a very small error. They have forgotten to include the comma between the two identifiers Fahrenheit and Celsius. This missing comma generates an error message, shown here in red, which is not only cryptic and mostly unhelpful, it is simply difficult to read. We propose that improving the readability of error messages is an important first step in making them more usable. However, we don't yet have empirically tested guidelines for making messages easier to read. In this work, we set out to answer two research questions. The first, to identify potential factors that might affect message readability, and the second, to measure the extent to which they do.
Now I'm going to give a brief overview of the three studies we ran, as well as discuss the results of Study 1. In Study 1, we asked participants to rate on a scale of 1 to 10 the readability of 60 error messages from three popular introductory programming languages, Java, C, and Python. In Study 2, we took a smaller number of messages and asked participants to explain in their own words what made them readable or not. And then in Study 3, we took results from Study 1 and 2 and asked students to rate a set of error messages with respect to what we had found in the first two studies. The results of Study 1 indicate that length and jargon were particularly important. The shorter messages were ranked higher, generally speaking, and the longer messages were ranked lower. Also, the messages with more jargon were ranked lower, while messages without jargon or acronyms were ranked higher.
To elicit potential factors that influence error message readability, we asked students to tell us what they felt made certain messages easier or harder to read. Responses indicated themes around message length, jargon, sentence structure, and vocabulary. In a separate study, we found that all four of these factors correlated reasonably with a measure of understandability. We present four concrete design guidelines for writing more readable error messages and apply these to messages from our dataset. Here is an example from C. Future work includes the creation of a readability metric for programming error messages. Finally, we hope that the guidelines presented here will aid in the creation of new programming error messages, as well as guide efforts to revise or enhance existing messages. Our goal is to see programming error messages become more readable and therefore more usable in the coming years, easing a decades-long struggle between countless novices and their programming environments.
Thank you very much for listening to this presentation. If you're interested, you will find more details in the paper, and if you have any questions, please don't hesitate to get in touch with us.